Hello everyone, this is Mrs. Ellsworth. Well, in this section we're going to be talking about mostly the scientific method, okay? But we're also going to be talking about science and technology and how they run hand in hand with each other to improve most of our quality in life, or how that they run hand in hand to enhance one of the other. You need science to increase your technology, and you need technology to increase your science. So that is most of what this section is about. So let's go ahead and start up so we can talk about the experiments in this scientific method. Okay, this reads here that science is a system of knowledge and methods that we use to find knowledge or to increase our knowledge on something. But if we're going to set up a science or an experiment using science, we're going to have to do it by two different types of experiments. One is a quantitative experiment and the other one is a qualitative experiment. Notice that this kind of got the root in here of quantity, quality. Okay, so if it's a quantity means it's a measurement. The measurements are numerical. Okay, so if I would go and find the do an experiment on the density of something, I could get 2.70 grams per milliliter. That is a value. Okay, that is a value. So this is numerical. So it's going to be a quantitative measurement that I got there. Now, if it's a qualitative experiment, okay, is it raining today? Yes or no? It's yes or no. Positive or negative. It does not have a numerical value. If somebody's going to get a pregnancy test, they're going to have to get, it's going to be positive or negative. Okay, and so that is the difference of those two measurements. But remember how I said that technology and science goes hand in hand? Well, just think, they started out with telephones where they had to open the receiver, and then they would get an operator that would direct them to whichever area that they need to go to. Okay, and then as time went on, when my mother worked as a telephone operator, they would have to get out of the area code, they'd have to call the operator and then go into another area code, and so then that they would connect them to the right one. But things advance. Technology advances. I remember when we got a phone like this, it had a redial button on it. That was pretty exciting. Okay, and then you could have also more than one line coming into an office so that you could direct a call and then go have your phone answer for another one. And so things kept on advancing. I think some of these are pretty funny to see. Most of us also got one of these fancy cordless phones at our house, but you know that most people don't even have a corded or a cordless phone in their house. Most people just now have just a smartphone. And that is just amazing. And believe me, what comes up next in technology will blow your mind too, because this stuff never existed when I was a kid. And things that are there now will still advance. And you're going to think that, well, they keep on telling us to educate kids for the future because you guys are going to be working on things that don't even exist now. That's exciting. Anyway, technology goes hand in hand. We need technology to increase our science needs, and also the science is used to help increase the technology. But one more thing that I want to talk about quickly before we get into science experimentation. Anyway, there are three branches of science, and we're going to be talking about this one, physical science, right now the most. But the other two is the earth and space science and life science. You talked about life science in 7th grade. Earth and space in 8th grade, and now you're going to be talking about physical science, which has two different portions to it too. There's physics, which is the second half of the year, and chemistry, which is the first half of the year. Some people say that chemistry is a central science, and that to know how the life science works, you need to know chemistry, and so I kind of put that in there to show that it's kind of a central science. But life science has plants, the environment, heredity, animal science. It's got all of that involved in it. In Earth and space systems, you've had that before. Geology has got to do with your rocks. Astronomy is with space, weather, and then also how that things change in the ocean, especially like plate tectonics. Anyway, this is what I've been leading to. Okay, when you are talking about the scientific method, you're seeing an observation. Okay, cooked onions taste sweeter than raw onions. Some kind of observation like that. And you might come up with a question, or maybe you'll go back and make another observation, or maybe you made a hypothesis from it. You know, you're coming up with a question about a situation and you want to know why certain things are, and it must be something that you can test. Okay, so you'll develop a hypothesis so that you would find out if it so you can find the answer to your question. So with that hypothesis, you're going to do an experiment. Okay, it must be testable again. So you'll do an experiment, and with the experiment, you'll start collecting data. And with that data, you can analyze it and draw a conclusion. Then you can find out whether or not your hypothesis is correct or not, and whether you have to go back and change it. Did you notice how my laser pointer has been going all over on here? This is not a set of steps that you follow, one right after the other. Okay? It's not a set steps. You may have to go back and tweak things, restart all over, okay? Or change it because you figured out that what you did was not good enough and that you learn more by making more observations or research so you could go back and tweak it. Well, also a hypothesis in a scientific method is something that is testable. It is a proposed answer. I know Mrs. Schoeneck, she gets really mad when you guys say it's an educated guess. It's a proposed answer to a question, and it is also very logical. Okay, now a theory is something that explains why something's going to occur. So a theory, we base it on lots and lots and lots of experiments. Okay, and it's not all the same experiment. Things change over time. Like plate tectonics, they were gathering evidence that occurred, but we will never be able to prove it. We will never be able to prove the Big Bang Theory. We will never be able to prove the atomic theory, but we keep gathering evidence. Do you know that the atomic theory, that they believed a long time ago that it was just one small little particle that made up an aluminum atom? Okay, but now we know that there's several subatomic particles and that there's particles within those subatomic particles. So we keep learning on more of it, and it will help explain how chemical reactions will occur, but we keep tweaking it, and we will never be able to prove them. We will just be able to get closer to understanding things based upon a theory. Now, scientific law is a prediction of what will always happen. Okay, like the law of gravity. Something's always going to fall when you let go of it. You can manipulate it different ways and it might make it so it doesn't fall, but in basic conditions it will always fall. Now, a hypothesis does not graduate into a theory, and a theory does not graduate into a scientific law, and students misconstrue that so often. Anyway, like I had said, that theories, that they have been changing over time and that they are accepted by scientists because they followed the scientific method, or else they did very logical sequences in their experiments so that everybody could trust what they did. Okay, so they are not set in stone. Okay, they are revised as they learn more information as time goes. So remember I talked about doing the scientific method? Well, let's think about this. How does our speed, whether you walk or run or jog or stand still in the rain, okay, how does that affect how much rain, how wet you get? Okay, so there's some facts that we know. We know that just standing in the rain, you're going to get wet. Okay, walking in the rain, you're in the elements longer. And running in the rain, you run into droplets. So how do you know what to do to be not as wet? Okay, so I made an observation there, several of them. Okay, and I asked the question, how does your speed affect how wet you get in the rain? And so we're going to develop a hypothesis. Okay, now remember, this has to be testable. Okay, oops. So we're going to make an experiment, okay, based upon our hypothesis, and it's going to be controlled. We're going to keep every variable consistent except for one, the one that we change. Okay, this is in our book they call this the manipulated variable, but it's the variable that we change. I call it the independent variable. Okay, in this case it's going to be whoever stands still, whoever walks, and whoever runs. Okay, the dependent variable is the one that we measure. Okay, the person who stands still, walks, or runs in the rain, we will measure how wet that they get. Okay, so everything stays constant. We'll have the same size kids running. We'll have them use the same exact shirt, except for maybe we'll buy a package of white shirts or something like that. And we'll have them, we'll make sure they all have the same exact mass or weight. Okay, and so we will test all of them so that they are in the same exact rainstorm. I mean, you want to make sure that one wasn't in a misty storm and one was in a downpour. So you want to keep everything constant so you have a nice controlled experiment. Okay, now you'll have a control group. That's the one that you always know your results. You always know the results. So that'd be your person standing still. Okay, he's going to get wet. If he doesn't get wet, nobody else should be getting wet. Okay, so this right here is the person who's just standing in the rain in this case. But your experimental group, it will be two of them in this case, two groups. It will be one who's jogging and one who is who's walking in. Okay, so that way you can make a good prediction of what will happen. Okay, so how does your speed affect how wet you get when you're caught in the rain? Okay, how would you set up this experiment? Okay, so you'd want to write a very good procedure that has a logical set of organization, and so that you can test your hypothesis. You're not going to have somebody with an umbrella in this one because that would not be logical. And so you want to make sure that everything that you're doing follows a strict guideline so that you will have a good controlled experiment. Okay, so your control is one that you always know what your answer will be. Okay, a single variable that you're changing is a speed. You're having different speeds of people in the rain. Okay, and you'll want to repeat this. You want to do it 3 to 5 times just to make sure that you got the right results. That wasn't just a fluke. Okay, so in this case right here, you could design another experiment that I'd like to talk about when we come to class. But let's do one more example. Okay, storing popcorn in the freezer makes it pop better. That's a hypothesis I've heard from people. Okay, so what will your control be? Pause it and think about what will you be doing so that you know what the results would be. Okay, your control is your regular one. Okay, you stored it at room temperature, and so then you'll be testing your single variable, which will be the storage temperature. Either it's at room temperature or else in the freezer. Maybe you could even do one in the fridge if you wanted to add another one, but everything else must be the same. The popcorn brand must be the same. They must have been purchased at the same time so that they're still both fresh. You can't do an Orville Redenbacher one with a Pop Fresh one, but you must have the same exact brands and freshness. Okay, also the storage time. They must be stored the same amount of time. You can't just go and throw one bag of popcorn in the freezer the day before you test it. They must be stored the same exact time inside the fridge and freezer and in your pantry. Okay, you must use the same exact popper. It doesn't make sense if you would have something different, because what if one burns it, the other one doesn't, or one's warmer, one's colder? You must use the same exact method. Okay, and from that you can come up with a good experimental design. What would be your independent variable? Remember, that is the one that you changed. Pause it, come up with one, and see what it is. What would be your dependent variable? Remember, that's the one you measure. So pause it, figure out what you would like to say here for your dependent variable. Okay, I don't know if you want to check how many popped kernels there are. It depends. I mean, if you didn't have very many pop in either one, I'd probably do the number of popped kernels. But in this case, we're hoping that this shows more fresher, so you're going to have a lot more popped kernels than unpopped ones. Okay, this right here, you can notice how I'm being a little bit picky about grammar. And I'd like you to note that quite often it seems like students need to be using the word affect instead of effect. So make sure that you're thinking about that. Okay, and I'll end this video now, and we will be discussing a procedure in class tomorrow. So be prepared to know what the independent and dependent variable is, and I will see you then.